So let's start off with a little presentation on terrain modification. Okay, so let's talk about terrain modifications this morning in HEC-RAS. Terrain modifications are a new feature that we've added in version 6. And so hopefully they will shed some light on how we can help modify our terrain model like we were talking about yesterday during the terrain modeling presentation. But there's two ways we can do this terrain modification. We can use existing tools that we call the terrain replacement using cross sections. Or we have a special set of vector tools that we can add right on top of our raster layer. So here we have that same data set we looked at yesterday and that you guys have been playing with. This is the Muncie, Indiana data set. And you can see in the main river, we have several locations where bridges are crossing. And again, as we talked about yesterday, if we had a 1D model, then not a big deal, right? We could always place our cross sections away from the bridge and still capture the conveyance of the main river. Well, what if we'd already created that 1D model, but we wanted to create a 2D model and we wanted to replace the channel information with bathymetric data that we'd surveyed and put into our cross sections? Well, we have the capability in RAS to take and lay out cross sections, modify the channel data. We then can, using that, we can identify bank stations. Now, typically when we talk about bank stations, we're talking about them from a hydraulic perspective, right? What part of the channel is conveying water and moving as a continuous flow block? When we're talking about bank stations in terms of channel replacement, we're talking about the extents to which we want to modify the terrain. So the bank stations we place here are more based on geometry and not necessarily based on flow. So we have cross sections, we have modified terrain, we place our bank stations for the area we would like to replace the data. And then RAS has tools that will automatically create bank lines from those bank stations. If you wanted, you could create those bank lines on your own. But what this is going to do is it's going to a couple things. It's going to, one, show the bounds for which we hope to do our channel replacement. And as you can see, these bank lines aren't perfect. For instance, down here, maybe we wanted that bank line to be a little bit higher to capture the low ground a little bit more. And maybe around this edge, we wanted to bring it out a little bit. So the first step is having cross sections with channel data. And the second step is creating a path or a swath for the bank lines of interest. You also will need to create a river line for those cross sections to live on and to follow the path of the center line. But once you've done that, Mark added several years ago the ability to interpolate the data from cross section to cross section. So this is going to allow for a linear interpolation from cross section to cross section using the shape of the river and the shape of the bank lines to do the interpolation. Once we've done that, we can then export the channel data based on its combined geometry with this interpolation surface. And so to do that, we right-click on the geometries layer, and we say export layer, and then you can choose to create a geotiff from either the entire interpolation surface, and here the interpolation surface is shown in black and white, where we're just interpolating, in this case, between two cross sections. If we're looking at two cross sections, you can see it's black by this cross section. That means that we're going to use a value of essentially in the entire value of this cross section, and then it's going to transition to entirely the value of this cross section. And so the shading depicts how we think the interpolation should occur. So you can export this surface either for the entire surface or for the channel only. And in this case, when we're doing a channel replacement, we just want to replace the channel. So we export that. And to export it, you have to give it a raster cell size because we're exporting a raster data set. At that point, you then have something that's living on disk. Okay, so we have our base terrain. We have our base terrain model. We'll call that, for the sake of a better name, base. And then on disk, after we've exported the data, we'll have another raster called channel. So at this point, we go through the same process that you've gone through already this week. We're going to now create a brand new RAS terrain by loading in your base terrain data and your channel data and making sure to set the priority for the channel data. Saying my base data is great for the overbanks, but anywhere that I have channel data, I want to use it. So we set the priority and then go through the creating the new RAS terrain by specifying a file name and deciding what type of rounding we want to do or vertical conversion. So the resultant of that is we have our base terrain data, and then when we've added our channel data, we have a seamless terrain model. And again, the terrain model that we create in RAS, it'll look like just one data set called with channel. On disk, we're actually pointing to two different terrain models, base TIFF and channel TIFF. Now, if you wanted to, say, merge all this into one terrain model, we have options in RAS where you can right-click on the terrain model and say export, and a dialog will come up and say, okay, you want to export this terrain. What do you want to use for its boundaries? Do you want to use the whole terrain model? Do you want to use just the geometry? And what cell size do you want to use? So you can create one combined terrain model. But we have a question: what do the tin stitches do? So yesterday during the workshop, I had you turn on the tin stitches when you brought in the data. Well, what happens is we have two different terrain models. We have the channel terrain model and we have the overbank terrain model. And when the two models are combined, we need to know how to transition from, let's say, the outside edge of our channel model to the inside edge of our main terrain model. So the triangulation, we perform triangulation between the edges of these two models to come up with a continuous elevation surface. So that's what the tin stitches does. We are trying to get away from having to recompute that. There's some instances where we need those to be pre-computed. For the most part, those tin stitches are computed on the fly anytime a user or anytime you need to extract elevation data. So for the most part, you don't have to have tin stitches turned on, which is this checkbox. You don't need to have that turned on for the most part. Really, you only need to have that turned on if there are holes in your terrain model and you want to fill in those holes. Hopefully you will have verified your terrain data before you started modeling, however. Okay, so once you've done that, then not only can you extract elevation data and you can have a good 2D model that's going to allow water to transmit through these barriers, for instance, but then you also have a good inundation map that will make sense when a non-engineer is looking at it. A lot of times if you publish a map that looks like this, the first question you get is where did the water go? And obviously the water is going under the bridge. But for a lot of people, seeing the water going continuously down the river is a much more calming or intuitive picture. Okay, so that's your introduction to using cross-section data to replace terrain data, and you'll work on that on the workshop after this presentation. All right, so let's move on to the fun stuff. Let's talk about terrain modifications. So for terrain modifications, we've added a new capability. It's a vector override to the terrain layer. And so you can go into any terrain that you've brought into RAS, and you can say, I'd like to add a modification layer. and we've grouped them into 3 different types: simple shapes, lines, and polygons. Our simple shapes are things for like circles, rectangles, and triangles, and these are special shapes. Not that circles are special, but we actually maintain an exact circle in memory in RAS and how we store the data. Same with rectangles and triangles. We also have, and these are intended to be for like piers or maybe a building you really want to represent. We also have elongated piers, and we'll take a look at what those look like, but that'll allow you to round the nose. We have lines. These are intended for high ground, such as roads and levees, or for burning in a channel. And then we have polygons, and we'll look at what we can do with a polygon. So the first thing we're going to do when we want to perform a terrain modification is we're going to want to clone the terrain. It wouldn't make sense if you're working with a large terrain model to make a copy of it, make your modifications, then make a copy of it, make your modifications, and so on. So Alex Kennedy had the great idea of, hey, we're going to use the same base terrain model. All we need is a way to stack information on top of the raster data. So we clone the terrain, and so when we clone it, oh, I don't have a screenshot of it. When we clone the terrain, all it does is creates a copy of this terrain model, and then you can append it with a name like clone. That is going to create a new HDF5 file on disk, so a pointer file to that terrain model, but we're not going to actually touch the underlying terrain. It's as it says up here, it's a virtual copy of the terrain, so we just have another file that points to it, which is great because then you're not going to be end up with a whole bunch of data on disk. At that point, once you've cloned your terrain, you can then go and say you'd like to add a modification. And here we've added an ellipse or a circle modification that I've labeled piers. And then I've gone in and I've dropped piers on here and provided some elevations, and that is automatically stamped into the terrain. So that's a real simple example. What's a little bit more complex example? Here's a pier, and this is where we're actually using the elongated pier function. And you can see this pencil that we put in there is a pier that's got a triangular nose on one side and a rounded nose on the other. So what does the editor look like? Well, for a simple shape, you're just going to have the stuff up at the top. You give it a name. You talk about how you'd like to replace the terrain. So we have several options here that we'll look at in the workshop. You can replace the terrain. You can add an elevation to the terrain. You can take the higher or the lower. But 99% of the time, you're just going to want to replace the terrain. You can give it an elevation. You can rotate the object. And then if it's a rectangle, or in this case, a pier, you can say how wide the object's going to be. So that information up here for this pier identifies the base shape, the base rectangle. You can also provide the length, and then you can provide different shapes for the rounding of the nose or the triangulation of the nose if you want. So that is the more complex pier shape. If we were just doing a circle or a square or a rectangle, you just have the input box up here where you put in your elevation and then some dimensions. The more fun one that you guys will probably use all the time is the ability to put in a polyline to represent high ground or the channel. In this case, we're just going to talk about the putting in high ground, but it's exactly the same for the channel. You just flip it upside down, or we flip it upside down. You don't have to. So in this case, we want to put in a proposed levee design. So we can just digitize our levee alignment. And then once we've digitized the levee alignment, we have a high ground editor that comes up that allows us to define the profile for this line. So in this case, I've defined real simply, I'm going to start at 0 station. And 0 station is always where you start your creation of the line. And then we'll be adding points that goes to the end. So at station 0, I put in an elevation of 943, and it's reflected in the plot next to it. At 400 feet along the line, I've got a little bit different elevation, a little bit of slope to it. At 800 feet, then we have a lower elevation, starts to come down, and then we try and tie it into the ground down near the bottom. Okay, so that's the profile portion of this. What we're actually adding or stamping into the terrain is some sort of trapezoidal shape. And you define the trapezoidal shape in the upper part of the editor, where you give it a top width, side slopes, and then how far out you actually want to impact the terrain model. So if I had this elevation very, very, very high, let's say way up here, well, if we had a side slope of 2 to 1, it would go way out, somewhere out into the overbanks. And if you don't want it to go out that far, you can have it just use that side slope for a certain distance, and then it will stop and get tied directly into the ground. It'll come straight down, like with vertical walls. So for high ground, we have a modification type called take higher. If we were putting in a channel, we would click this drop down and we would choose the take the lower value. And so it would stamp in an upside down trapezoid. But all the data is entered in the same way. And then the last thing up here at the top, this is this thing called snapping tolerance. We're going to talk about that in a minute, but that has to do if you want to control the elevations along the line using individual points, how close you need to be for that point to affect the line. So we'll look at that in just a second. Okay, so the first question you're probably asking is, okay, that's great, Cam, but I don't really want to type all this information in by hand. So if you have, National Levy Database in Excel, you could, after you brought in the alignment, you could copy and paste the station elevation data into this table, or you could just import the NLD from a shapefile. So we've been working on the shapefile import for quite some time now. It can import shapefile Z. So if you have the Z component in the shapefile, it will bring that in and automatically populate the station elevation table. If you do not have shape elevations in the shapefile, it will just bring in the XY coordinates. So it'll bring in the alignment, and then you'll be required to put in the station elevation data by hand. You can also, as you've probably already witnessed, you can click on any layer. You can right click on it and ask to import a shapefile, and it will give you a very detailed mechanism for importing individual shapes. So you can bring in individual shapes from a shapefile by right clicking on the layer and selecting the feature of interest. Okay, so we talked about this snapping tolerance, and this snapping tolerance goes with this idea that we have elevation control points. Elevation control points allow us to click on any location along a line and add elevations. So here we're adding an elevation control point. You can see the green crosshairs. That indicates that I'm close enough that the point will be snapped to the line. When I drop that point, a dialog will come up and it will say, it should say the elevation for this point is whatever the terrain model thinks it is. And it'll be in the box here, and then you can override it with the elevation that you'd like. So that gives you finer control over what's happening. Once you've added elevation control points, now you can see I'm looking at the same levy that we started with. So we started with our initial levy where we entered 4 points, 4 elevations in our table. Then we went back and said, you know what, I want to modify this by hand a little bit more. Now when I look at this station elevation table, you'll see there are some rows in the table that are grayed out. Those are being controlled by those elevation control points. The values that are white are values that I've typed in by hand. Now, do I expect you to do this for the most part when you're creating your levy? No. Most of the time you're going to have a shapefile and you're going to import it, or you're going to have a spreadsheet with station elevation data and you're going to copy and paste it in there. But we've provided you the flexibility to enter data in 3 different ways so that you can combine whatever methods and data you have to get a good profile for the line. So here you can see station elevation, and so on. You'll see the profile that's being reflected is reflected in the picture based on the data you have in the table. What happens once we've got our terrain modifications complete? Well, when we stop editing and we go to cut information, here we've got 5 piers crossing the river. Once you cut a profile, then you'll be able to see this was my original cross section here shown in green. Here's my piers that I've added to the terrain shown in brown. So that's the new elevation profile. At this point, then I can right click on my cross section and I could say update my cross section, or in the case of a 2D model, you would recompute the hydraulic tables. And so the plotting tools we have available will tell you both what data has already been extracted, for instance, for a cross section, but also the profile will automatically reflect any of the modifications that you have in the terrain modifications group. Now, the cool thing about this that we didn't talk about, all these modifications, they're all these vector additions, you can copy and paste them. So if you go to the work of putting in a river, and then you want to use that river to cut the bathymetric data in, you can go up to the river layer, which would be up here in the layer list, select that river layer, and then paste it down in your line modification. So you can use the different lines in any layer, just copying and pasting and move them around. So it doesn't, or you could import them. So you don't have to go through the process of continually regenerating something that you've already generated. Okay, and then so we talked about simple shapes. We talked about the line capability. Let's talk real quick about polygons, and then I'll open it up for questions. So for the terrain modifications for polygon layer, here I've labeled it wetland, but this is just a polygon. You're going to do something like this similarly to this in the workshop. You draw the polygon just like any other shape in RAS. And then you have the editor that comes up allows you to provide a name. And then these are radio buttons, but we'll probably get, they don't really work like radio buttons. You can either, if you imported a shapefile, you could use the elevations from the shapefile if it was a shape Z. You can choose to use the elevations at the boundary of the terrain model. So what it will do, it'll pick up elevations along the perimeter and hold those constant. Then you would add elevations interior to the polygon, as I've shown here with my black dots. These are my elevation control points. Or if you unclick this use elevations at the boundary from the terrain, you can type in just a single elevation. So Walmart is coming in here. They're gonna bulldoze and make this one flat pad. You could go in and create that pad using the boundary and then just put a single elevation of 950 feet. So there's lots of flexibility there. For the most part, I think when people are creating these complex polygons, they're going to want to tie the elevations in directly with the terrain model. So the default value is to use the elevations at the boundary. And then once you've done that, you'll go through and add those elevation control points, which are always a subset for any point or polygon. It's a subset, so you would select that layer. Once you've selected the layer, you can then start adding points and entering an elevation. So here I'm entering an elevation in the center of this, and it says that the base terrain value for the land surface is 942 feet. What elevation do you want to put it at? I'm going to put it at 930. Click OK, and the data is going to start triangulating these control points with the perimeter. Here you can see a little bit of the triangulation that's going to occur. You can see this point is triangulating out to the edge of the polygon we've selected, and then it's starting to triangulate interior with these points. Now, the one thing to say about the control points, they're great, and they're going to allow you to modify the terrain elevation in almost any way you desire. But One little caveat is if you want to control the perimeter elevation, say you want to raise this up just a little bit or lower it just a little bit, you have to drop the control points on the outside of the perimeter. Any point that is dropped on the line or interior to the line is going to control the triangulation and the elevation of the surface on the interior of the polygon. Okay? In RAS, when you draw boundary conditions, if you add an interior boundary condition, it must be fully contained within the RAS model. If you're doing an exterior boundary condition, you want to have it completely exterior to your mesh.